At 04:12 a.m. on December 11, 2025, a radar operator at the Kazan Strategic Aviation Plant is staring at 13 faint red dots that just materialized on his S-400 screen. He doesn't know it yet, but he is looking at the absolute end of Russia's strategic air power. Just 72 hours ago, Vladimir Putin signed a televised decree ordering this specific plant to double its output of nuclear-capable bombers to teach Kyiv a final lesson before Christmas. Well, the lesson has been received. The tuition bill just arrived, and the price tag is measured in billions. To understand why the Kremlin is currently in a state of absolute paralysis, we have to look at the math, because the math says this strike is impossible. Kazan is buried deep in the Russian interior, 750 miles from the Ukrainian border. That is roughly the distance from New York City to Chicago. Between Kyiv and this factory lies the densest air defense network on the planet. 3 concentric rings of S-400 batteries, nasty little Pantsir-SM point defense systems, and the all-seeing Voronezh DM over-the-horizon radar. Overhead, combat air patrols of Su-35s and MiG-31s fly 24/7. On paper, this target is untouchable. Western military analysts stated that the only thing capable of penetrating this airspace is a stealth cruise missile costing $3 million a unit. Ukraine looked at that analysis, cracked a smile, and said, "Hold my borscht." At 09:15 p.m., deep in a forest near Kursk, 13 unmarked civilian delivery trucks, the kind usually carrying bread or frozen fish, open their rear doors. 13 Liutyi AN-196 drones are rolled out on rails and punched into the night sky. But here is where the genius kicks in. These drones aren't trying to outrun the Russian air defense, they are trying to bore it to death. The flight computer on each Liutyi locks the throttle at exactly 110 miles per hour and drops the altitude to a terrifyingly low 150 feet. To a fighter pilot, 110 mph is stalling speed, but to the billion-dollar Voronezh DM radar scanning the horizon, 110 mph is invisible. To keep the radar screens from being cluttered by millions of migrating geese or trucks on the highway, Russian systems are programmed to automatically delete any track moving slower than a Cessna. By flying slower than a Lada struggling up an icy hill, these drones are effectively hacking the enemy's operating system without writing a single line of code. And they aren't flying in a straight line either. The swarm activates the Ghost Flock protocol. Instead of a military formation, the AI creates a randomized zigzag pattern, mimicking the erratic movement of birds fighting a headwind. They dive into the freezing fog rising off the Volga River, using the -5-degree industrial smog as a physical cloak. On the Russian side, the radar operator sees a faint cluster of static, assumes it is a flock of geese migrating late for the winter, and takes a sip of his tea. Back in a concrete bunker in Ukraine, a team of engineers stares at their monitors, coffee gone cold hours ago, watching the telemetry tick down. 700 miles to go, one whispers. Keep it steady, Putin is still sleeping. At 01:22 a.m., 400 miles deep inside Russian airspace, the law of averages finally catches up with the swarm. High above the freezing cloud deck, a Su-35S Flanker E, Russia's premier air superiority fighter, is flying a boredom patrol. The pilot is half asleep until his OLS-35 infrared sensor screams for attention. The Liutyi drones might be invisible to radar thanks to the Doppler notch, but they are powered by internal combustion boxer engines. In the freezing -5-degree air of the Volga Valley, those little exhaust pipes glow on a thermal camera like a cigarette tip in a dark cinema. The Russian pilot frowns. He doesn't wait for permission, he flips the master arm switch and launches 2 R-77-1 air-to-air missiles. These are million-dollar active radar homing killers designed to shoot down F-16s, not fiberglass model airplanes. The missiles accelerate to Mach 4 in seconds, closing the distance instantly. 2 flashes of light illuminate the fog bank below. 2 Liutyi drones on the outer edge of the formation disintegrate into confetti. The pilot smirks, radioing back. Targets destroyed, airspace clear. He thinks the party is over. He thinks he just won the war. He is wrong, he just paid the cover charge. Down in the Kazan command bunker, the mood shifts from boredom to absolute panic. The destruction of those 2 drones confirmed that this isn't a glitch, it's a raid. The dormant air defense network wakes up screaming, "Scramble the MiG-31s! Lock everything down!" Back in Ukraine, the telemetry screens for Drone 12 and Drone 13 go black. The operators don't mourn, they calculate. The element of total surprise is gone. Now the game changes from stealth to survival. "They know we're here," the mission commander says, his heart rate monitor spiking on his smartwatch. "Upload the new flight profile. Increase zigzag randomization by 20%. Turn them into ghosts." The remaining 11 drones instantly snap into a more aggressive, erratic flight path, banking hard left and right, effectively becoming the Volga Phantoms, just as the entire Russian air defense grid lights up red. At 02:45 a.m., the Russian air defense grid is fully awake, and the S-400 batteries start painting the sky with enough radar energy to microwave a frozen chicken. This is the moment the swarm should die. Instead, the remaining 11 drones activate a feature that wasn't in the manual: Mirage Mode. This is the intellectual haymaker. The Liutyi drones don't try to jam the Russian radar with brute force, they simply start lying to it. Powered by an upgraded AI vision system, the drones begin broadcasting a specific electromagnetic signature at 2.4 GHz. They aren't mimicking birds anymore. They are mimicking the target itself. The AI has learned the specific industrial noise generated by the massive ventilation fans and power transformers of the Kazan aviation plant. On the Russian radar screens, the distinct attack vectors dissolve instantly. Instead of 11 hostile targets, the operator suddenly sees a massive, confusing blob of industrial clutter that seems to have detached itself from the factory and is floating down the Volga River. It is digital camouflage at its finest. The operator freezes. He can't tell if he's looking at an enemy drone swarm or if his own radar is malfunctioning due to interference from the plant's heavy machinery. Taking advantage of this confusion, the swarm drops to a suicidal 50 feet, literally skimming the freezing water of the Volga, using the dense industrial smog as a physical shield. The S-400 computer tries to reacquire a lock, but every time it paints a drone, the AI detects the beam and jerks the aircraft vertically in a pre-programmed evasion maneuver. Inside the command vehicle, chaos reigns. The Russian commander is screaming profanities. He can't authorize a launch because the signal looks exactly like local interference, or worse, his own electronic warfare units testing their gear. He orders a switch to manual optical targeting, but the hesitation is fatal. It takes his crew 12 minutes to override the safety protocols. In modern warfare, 12 minutes is an eternity. At 03:08 a.m., the AI's clever jamming runs into a problem that code cannot fix: human stubbornness. Inside a Pantsir-SM vehicle, a veteran lieutenant colonel who hasn't trusted a microchip since the Soviet Union fell decides he has seen enough glitches for one night. He slams the manual override button, bypassing the confused targeting computer entirely. "Screw the ghost signals," he mutters, grabbing the joystick. "I'm shooting by eye." He slews the optical tracker toward the southeast, spotting the faint silhouette skimming the river against the moonlight. He fires. Not a warning shot, but a full salvo. 4 57E6 command-guided missiles scream off the rails. At this short range, the AI has no time to spoof. Physics takes over. 4 consecutive explosions rip through the formation, sending burning carbon fiber raining down into the icy black waters of the Volga. The swarm is cut down to 7, but the gunfire has broken the spell. The confusion is gone. The entire Tatarstan region goes to red alert. From an airfield just outside Kazan, the ultimate predator takes flight: the MiG-31BM Foxhound. This isn't a dogfighter, it is a flying missile battery capable of Mach 2.8, designed specifically to hunt cruise missiles. It is carrying R-37M hypersonic missiles that can kill targets 200 miles away. The flight time to intercept is exactly 9 minutes. Back in the Ukrainian bunker, the cheering stops dead. The room temperature seems to drop 10 degrees. The swarm is exposed, the element of surprise is ash on the riverbank, and the fastest interceptor on Earth is burning the sky to meet them. The operator's hand trembles slightly over the keyboard. Engage the final protocol. It's now or never. At 03:17 a.m., the MiG-31BM arrives over Kazan like a thunderclap, its twin Soloviev D-30 engines screaming. The pilot has his finger on the trigger of an R-37M hypersonic missile, ready to vaporize anything with a heat signature. But when he looks at his sensors, he sees nothing. Seconds before the interceptor arrived, the Ukrainian operators played their final card, Volga Phantom Mode. The 7 remaining Liutyi drones simultaneously cut their fuel flow. The propellers stopped spinning. The engines went cold. Instead of fighting the air, the drones engage their flaps and drift toward the massive thermal columns rising from the Kazan Thermal Power Station's 5 industrial smokestacks. The exhaust gas here is pumping out at 400 degrees Fahrenheit, creating a massive invisible elevator of hot air. The drones catch this updraft and begin to circle, gaining altitude without burning a drop of fuel or emitting a single decibel of noise. The MiG-31's Zaslon-M radar is looking for fast movers. Its thermal seekers are looking for hot engines. Instead, the pilot sees 7 cold, slow-moving objects drifting lazily in circles near the smokestacks. To the sophisticated onboard computer, this fits only one profile: a flock of large birds riding the thermal currents to stay warm. "Tower, this is Foxhound," the Russian pilot growls, frustration leaking into his voice. "I have no targets, just some massive kites or birds circling the power plant. I'm not wasting a $2 million missile on a pigeon." He banks hard and hits the afterburners, booming back toward base to complain about broken sensors. As the roar of the jet fades, the birds suddenly stop circling. In the bunker, the Ukrainian team isn't laughing. They are executing. "The dog is gone," the commander says. "Feed them." In the 11 minutes of golden silence that follows, the 7 drones exit the thermal column. They don't restart their engines, they simply trade their altitude for speed, entering a silent, terrifying glide. The AI locks onto the geometric shapes of the Tu-95 assembly halls below. Gravity takes over. 7 warheads, each weighing 165 pounds, silently scream toward the roof of the Russian strategic bomber fleet. The wolf is at the door and the wolf isn't even knocking. At 04:52 a.m., the command comes from a secure terminal in Kiev. It isn't a speech, it isn't a shout. It is one single word typed into a command line: fire. 7 Liutyi drones, now acting as 165-pound unpowered gliders, cross the perimeter fence of the Kazan plant. Their onboard inertial navigation systems, cross-referenced with the WGS-84 coordinate grid, align them with a terrifying precision of 3 meters. They don't aim for the walls, they aim for the skylights. The first drone punches through the corrugated steel roof of Assembly Hall 4. It doesn't detonate on impact. That would be amateur hour. The fuse is set with a 0.8-second delay. It punches through the roof, falls through the rafters, and buries itself deep inside the hollow fuselage of a Tu-95 MS being retrofitted on the floor. For a fraction of a second, there is a metallic clang that echoes through the cavernous hall. Then, physics takes the wheel. The explosion isn't just loud, it is scientifically cruel. The warhead isn't filled with standard TNT. It is packed with PBX-75, an aluminized thermobaric mixture designed to burn at 8,500 degrees Fahrenheit. When it detonates, it doesn't just push air. It sprays molten aluminum in every direction like a hyper-lethal Christmas firework. The Tu-95 Bear is built largely from magnesium alloys and composite insulation, materials that are lightweight for flight but heavily flammable on the ground. The initial blast atomizes the drone, but the secondary thermal pulse ignites the bomber frames themselves. Within 40 seconds, the magnesium skins of 6 incomplete bombers catch fire. Magnesium doesn't burn like wood. It burns like a flare, blindingly white and impossible to extinguish with water. The shockwave, trapped inside the reinforced concrete walls of the factory, doubles back on itself, crushing the delicate jigs and calibration tools required to build these giants. The factory has effectively become a pressure cooker filled with liquid fire. By 05:12 a.m., the roof of the Kazan plant collapses. The satellite feed from Maxar, passing overhead just 20 minutes later, confirms the catastrophe. 6 out of the 8 active assembly lines are buried under molten slag. The warehouse storing the specialized swept-wing components, parts that took 3 years to fabricate, is now just a smoking crater. The immediate human cost is grim. 127 senior aerospace engineers and specialized technicians, the irreplaceable brain trust of Russia's strategic aviation, have been permanently removed from the payroll. On the ground, Spetsnaz units rush to cordon off the area, confiscating phones and threatening locals, trying to hide the sun with a thumb. But they can't hide the pillar of black smoke rising 2 miles into the dawn sky. It is a beacon of failure visible from space. The shockwaves travel faster than sound, reaching the Kremlin before the fires are even out. The damage assessment is catastrophic. Russian strategic aviation has just lost 70% of its production capacity in a single night. The existing fleet of Tu-95 bombers is aging rapidly. They have airframe fatigue that limits them to maybe 5 to 8 more years of service. Moscow planned to replace them with the new units being built in Kazan. Those units are now puddles of metal. This means that after 2033, the Russian nuclear triad will effectively lose its air leg. The bear is officially an endangered species. In the short term, the impact is even more humiliating. Putin's grand plan to rain 100 glide bombs a day on Ukraine for Christmas is dead on arrival. The logistics chain is paralyzed. The paranoia sets in. Russian commanders are now seeing ghosts in every shadow, delaying decisions, grounding flights, and second-guessing their own radars. The chain of command is broken. Let's close the books on this one. Ukraine spent roughly $700,000 on drones, fuel, and bread trucks. In return, they destroyed $1.2 billion in aircraft and set the Russian strategic bomber program back by a decade. That is what we in the business call asymmetric dominance. They proved that in the 21st century, you don't need a nuclear missile to kill a superpower. You just need a lawnmower engine, a cheap AI chip, and the audacity to turn your enemy's own industrial noise against him. The lesson for today is simple. Don't poke the nation that can turn a washing machine into a weapon of mass destruction. Glory to Ukraine, and to the heroes who just turned the Russian bear into Russian barbecue. So, what's next? If you were sitting in the commander's chair in Kyiv, where would you send the next swarm? Would you finish the job at the Tu-196 plant next door, or would you send them north to the nuclear submarine yards in Severodvinsk? Let me know your battle plan in the comments below, and I'll analyze the best strategy in the next video.